Hey! This is awesome! Let's dive deeply into the fact that by applying even pressure to an egg, it is nearly impossible to break the shell by squeezing it. I am pretty sure that most of the maximum of you know it, but I am definitely sure that physics behind it will baffle you for a moment. Let's start. While it may seem counterintuitive, applying even pressure to an egg can indeed make it surprisingly resilient to breaking. This phenomenon can be attributed to the egg's unique structure and the principles of physics at play. Eggshells are composed primarily of calcium carbonate, arranged in a lattice-like structure. This structure is designed to provide strength and protection to the delicate contents of the egg. When pressure is applied evenly to an egg, the force is distributed across the entire surface area of the shell. This distribution of force prevents any one area of the shell from experiencing excessive stress, reducing the likelihood of fracture. Moreover, the shape of an egg further enhances its ability to withstand pressure. The curved shape of an egg distributes external forces more evenly, minimizing the concentration of stress points. This structural design helps to dissipate the force applied to the egg, making it less susceptible to breaking. Additionally, the contents of the egg, particularly the egg white, albumin, play a crucial role in its resilience. The egg white acts as a cushioning layer, absorbing and dispersing external forces. This protective barrier helps to shield the delicate yolk inside the egg, further reducing the risk of shell breakage. However, it's essential to note that while applying even pressure to an egg can make it highly resistant to breaking, extreme force can still overcome its structural integrity. Excessive pressure or sudden impacts can cause the eggshell to fracture, especially if the force is focused on a particular area or if the shell has any pre-existing weaknesses, such as cracks or thin spots. Conclusion: the ability of an egg to withstand pressure is a fascinating example of its remarkable structural design and the principles of physics. Hey! Wait! There's more! Let's look exactly at the principles of physics behind it. The principles of physics, such as Newton's laws of motion and Hooke's law of elasticity, govern how an egg responds to applied force. Understanding these principles helps explain why an egg can withstand moderate pressure when force is applied evenly. So now let's just revise or learn again about the laws or principles. Newton's first law of motion states that an object at rest will remain at rest, and an object in motion will remain in motion unless acted upon by an external force. In the case of an egg, when it is subjected to pressure, the external force is applied to the shell. The egg remains stationary until the force applied to it overcomes its inertia and causes it to deform or break. Newton's third law of motion states that for every action there is an equal and opposite reaction. When pressure is applied to an egg, the eggshell exerts an equal and opposite force in response. This reactionary force helps distribute the applied pressure across the shell's surface, minimizing stress concentration points and reducing the risk of fracture. Thirdly, the Hooke's law of elasticity describes the behavior of materials under elastic deformation, stating that the extension of a spring or elastic material is directly proportional to the force applied to it, as long as the material remains within its elastic limit. In the context of an egg, the eggshell exhibits some degree of elasticity, allowing it to deform slightly under pressure without immediately breaking. This elasticity helps absorb and dissipate external forces, reducing the likelihood of fracture. Finally, jumping over to the conclusion. These physics principles collectively explain why an egg can withstand moderate pressure when force is applied evenly. The egg's response to applied force is governed by the laws of motion and elasticity, which dictate how the shell distributes stress and reacts to deformation. Understanding these principles helps elucidate the mechanical behavior of an egg under pressure and its remarkable ability to resist breaking under certain conditions.